As we're working with derivatives in calculus, sometimes we'll find out that actually finding the derivative is not the goal of our problem. The goal is actually to use the derivative for something else. So we're going to be exploring one of those ways in which the derivative can be used to find another problem. One of the most popular areas is finding equations of tangent and normal lines. So at the end of this lesson, you'll be able to use the derivative to find an equation of a tangent line and a normal line to a function. Right, first of all, how do you find an equation of a tangent line? Well, same thing if you're finding the equation of the line, we definitely want to end up with something that says y equals mx plus b. 3 steps that we'll use, and then we'll do some examples. If necessary, first of all, we'll find the y value of the point by plugging x into the equation. And by equation, I mean the original equation. Right. The next thing that we're going to do is to find the derivative, because remember, when we find the derivative, that will give us m, or that will give us the slope of the function. And then we will use y equals mx plus b to find the equation of the line. So it's mostly taking a few items that we already know how to do and putting them together. So let's look at this first example. We will be finding an equation of the tangent line and then the normal line to the graph of f at the indicated point. Our first function is f of x equals 3x squared plus 2x minus 1 at the point 2, 15. Some of these problems you'll be able to use your calculator on, and some of them you won't. It will say in the directions. This one we're going to do non-calculator. So let's go ahead and get started. Right, the first thing that I know, I am given an x and a y, so I'm good to go with that, so I don't need to find the y. The second thing that I want to do is actually to find the derivative, because that will help me find the slope of the line. So the derivative, using my derivative rules that we learned in the last lesson, bump my 2 out front, I'll get 6x plus the derivative of 2x is 2, and then the derivative of minus 1, since it's a constant, is 0. So that's my derivative. What I'd like to do is now find the derivative at the x value of 2. So we're going to find the derivative at 2. When I do that, I'll just plug in 2. And when I do that, I get an answer of 14. So now I have found the slope of my tangent line. The next thing that I want to do is actually use y equals mx plus b. I'll use the point that's given in the problem and my slope to find b. So I'll have 15 equals 14 times x plus b. So I'll get 15 equals 28 plus b. If I solve for b, by subtracting 28 from both sides, I'll get b equals negative 13. So the equation of my tangent line is going to be y equals 14x minus 13. And what we found at that point, x equals 2, that's the line that would hit the graph at that one spot and go through the graph. All right, the next thing, this was part A. Part B is just to find the equation of a normal line. If you remember from looking on our test the last time, a normal line just means the line is perpendicular. It's just another way of stating that. So we just want to find a perpendicular line to the tangent line. So the only difference is the equation, we already found that the slope was 14. So our slope is not going to be 14. Our slope is going to be the opposite reciprocal, which will be negative 1/14. Okay, I'm still going to use the point 215 because that did not change. So now we're just ready to go ahead and find b. So y equals mx plus b. We know y is 15. We know m is negative 1/14. We know x is 2 plus b. So I get 15 equals, this would equal negative 2/14, which actually gives me negative 1/7 plus b. Then I'll add 1/7 to both sides. We're not multiplying, we're just adding to get rid of it. 15 plus 1/7 is 15 and 1/7. So the equation of my normal line will be y equals negative 1/14 x plus 15 and 1/7. And there we go. All right, let's try one more example. On this one, again, we're going to find the equation of the tangent line and of the normal line, and we are going to go ahead and use our calculator for this one. So the first thing that I'm going to notice, though, we're given an x value, but we're not given a y value. So we're going to find that y value by plugging the 5 into the original equation for the x. So if I do that, I'll get the square root of 5 plus 4, and that will be the square root of 9, which gives me 3. So the point that I'm going to be concerned about is the point 5, 3. All right, let's go ahead. The next thing that we want to do is actually to calculate the derivative at 5, and we're going to let our calculator do the work for us. So please, at this time, get your calculator out while I get mine out. All right, you'll notice that I've gone ahead and typed in the equation y equals square root, and then quantity x plus 4. And what I'd like to do again is find the derivative at the point x equals 5. So we need to quit. So we'll do second quit. And then we'll go ahead and do math. Let's clear off the screen that's already there. We're going to do math 8 because that will find us n deriv. We would like to go ahead and go to vars, y-vars, function, y1, because that's telling us where we want to get that derivative equation from, and then comma with respect to x, comma, and we'd like to find it at the point 5. So go ahead and do that. And then go ahead and press enter. Notice I get 0.1666667. I recognize that as being the fraction 1/6. So let's go back to our problem here. So we found that the derivative is equal to 1/6. So now we can go ahead and use y equals mx plus b. That did find us the slope. That's why we did that. So now the y value is 3, the m is 1/6, the x is 5, and then plus b. So now I have 3 equals 5/6 plus b. I'm going to next subtract 5/6 from both sides. So 3 minus 5/6 would be 2 and 1/6 will equal b. So the equation of my tangent line will be y equals 1/6 x plus 2 and 1/6. All right, that was part A. Now let's go ahead and do part B. Well, we already found that our slope was equal to 1/6, but if I have a normal line, we're going to use the perpendicular slope, so the opposite reciprocal of that would be -6. So that's the slope that I'm going to use. We'll have now y equals mx plus b. The y value is 3, the m is -6, the x is 5, plus b. Just continuing to solve for b, I get 3 equals -30 plus b. Adding 30 to both sides, we'll get b equals 33. So the equation of my normal line will be y equals -6x plus 33. And there we go. So hopefully now you're able to find an equation of a tangent line and a normal line.